I am Astrobit, also known as Brian Mulligan, graduate student here at UT. My partner in crime is went home for winter break this month, so I'm on my own. But we're going to start this month with the lowest of the low, space poop. So NASA announced the Space Poop Challenge back in November. It's intended to help astronauts who are stuck in their spacesuits for long periods of time to figure out how to take care of business. This is a $30,000 challenge open to the public, so all of you can submit your ideas of how to deal with space poop for 140 hours when you're stuck in your spacesuit. However, unfortunately, you've only got about 2 hours left to submit your idea. So the website is up on the top here, herox.com/spacepoop. They're taking all entries from the public. Whatever crazy ideas that you have, submit it. Maybe you'll win $30,000. The winners will be announced at the end of January, so probably our February Astronomy on Tap, I will be telling you about how we deal with space poop. All right, going into less bodily functions. Leslie Morrison of Royal Greenwich Observatory in London looked back at Babylonian records of eclipses going back to about 720 BCE. Oops, that's not supposed to be up yet. They looked at the eclipse records of the moon passing in front of the sun, causing a solar eclipse going back for roughly 3,000 years. And discovered that about 3,000 years ago, the eclipses were happening 7 hours earlier than we expected. Now, 7 hours in 3,000 years doesn't sound like that big of a deal, but it actually gives us information about how the Earth is slowing down over time. The Earth spins, as we all know. We know that the day-night cycle occurs. The moon and the tides from the moon cause the Earth to spin to slow down over time. For the longest time, we thought this was happening at about 1.8 seconds over every 100,000 years. Their study discovered that it was actually happening at about 2.3 seconds per 100,000 years, about 20% larger than expected. On a related note, nope, no space poop. On a related note, space poop. On a related note, don't forget to set your clocks ahead or behind 1 second come this New Year's Day. We have a leap second this year. It's being added to the end of the year. This is essentially a correction to make sure that things like GPS and your cell phones keep track with the rate of rotation of the Earth. If we waited another million years, your cell phone would be off by a few hours. I know that's really important. Okay, the next story here, this is kind of fun. And this is kind of an unusual story for us. One of the things that I do when I'm looking up astronomy in the news stories is look to see who the lead authors are and find some sort of local connection. This is an extremely local connection. A large reservoir of ice was found on Mars, about the size of New Mexico. The author is Cassie Sturman. We are very privileged. Cassie, will you please stand up? Cassie is up top. Yep. Cassie is a graduate student here at UT Austin in the Jackson School of Geosciences. Please feel free to stop by and say hi to her. I've asked her to come and give a talk sometime next year, so please keep coming. You'll get to hear more about this. But she published a study last month. She used NASA's Mars Reconnaissance Orbiter to use kind of radar signals bouncing into the subsurface of Mars and discovered this giant ice deposit. It ranges from about 260 to 560 feet thick. It's located between about the 40 degrees north and 50 degrees north latitude on Mars. We would not expect ice to normally occur in this region, so it's suggestive of Mars having a different orientation of its axial tilt, kind of the same thing that causes seasons here on Earth. Mars's tilt ranges over time, and so if its tilt was different in the past, it would have allowed ice to form in this region. One of the particularly exciting things about this is there's water ice. There's a lot of other junk that's stuck in there that you don't want to drink. But this might make it a lot easier to explore Mars when we send crewed missions up to Mars hopefully in the next 10 years, depending on how things go. And we'll be able to extract water directly from the subsurface of Mars. This is also going to be a great place to look for life, because as we know, life very much requires water to survive. Talking of oceans or water under the surface, Pluto might have a very slushy, salty ocean under its surface. James Keene of the University of Arizona and Francis Nimmo of UC Santa Cruz were looking at the geography of Pluto and determined that there might be a subsurface ocean on Pluto. What's called the Sputnik Planitia. Sputnik Planitia, this part of the heart of Mars, or heart of Pluto, which you all learned about in the last year or so. That is a large depression in the surface of Pluto. It's suspected to be where a large meteor or asteroid crashed into the planet, dug out a crater or something like that. But it's depressed below the rest of the surface of Mars. It's a big basin. This area is on the opposite side of Pluto from its moon Charon. For that to have happened means that big deposit must be a lot more massive or more dense than most of the rest of the planet. And though that's suggestive of a giant subsurface ocean, which is something that we did not expect on Pluto. Pluto is about minus 400 degrees Fahrenheit. As a reference, we had one of the coldest nights that I've experienced here in Austin just a couple days ago at 26 degrees Fahrenheit. My friends up in Minnesota were experiencing minus 20 degrees Fahrenheit this last week, and probably still are. I don't want to go up there right now. Minus 400 degrees Fahrenheit is far, far worse. So don't bring your bathing suits. It's not going to go well. But this is very exciting. It's the possibility of another ocean on yet another planet within our solar system. And then finally ending, oh, no, not quite, superluminous supernova. So supernova, as Serafina talked about, are exploding stars. Superluminous supernova are supernova-like events that are 20 times or up to 50 times brighter than normal supernova. We don't understand them. We don't know what they are. A study came out from a couple of recent speakers, and Astronomy on Tap ATX. I'm having so much trouble with this. So Dr. Craig Wheeler, my advisor, Serafina's advisor, I think he's still out there in the audience, as well as Andy Howell were involved in the study looking at a particular superluminous supernova that was detected in 2015. On the left side is an image of the galaxy itself, that red blob. About a year later, so this is in 2014, about a year later there was a supernova. You see that the supernova is brighter than the galaxy itself. You can't even see the galaxy anymore. This team determined that this supernova is likely actually a black hole swallowing a star. So a star that gets star-like the sun, essentially, that got a little bit too close to the central black hole in the star, the supermassive black hole in the center of that galaxy. It got too close. It got shred apart by the tidal forces of gravity near that black hole, and it got so bright that it looked exactly like what we call a supernova. This is a new idea or new discovery of what these particular classes of supernova might be. Very, very, very exciting. All right, and finally ending on a very somber note, astronaut and Senator John Glenn passed away on December 8th. He was one of the first military pilots selected to participate in the space program. He flew on Friendship 7. He was the first American to orbit the Earth in 1962. He was the last surviving member of the first class of astronauts, the Mercury 7. After retiring from NASA and the military, he served as a U.S. Senator from Ohio from 1974 to 1999. He flew on the space shuttle in 1998 at the age of 77 in order to learn more about the effects of aging on, or the effects of space and aging on the human body. He was an inspiration for myself as well as many, many aspiring scientists, astronauts, and other people the world over. So thank you, John Glenn.